Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm answering this question submitted by a student. This is a very easy, simple trigonometry question. The student's probably just getting started in trigonometry here. So I'm just going to draw a little graph here. So the problem tells us that the angle's in the first quadrant. So here it is. There's our angle. I'm going to just draw a right triangle here, just to make it a little easier for you to see what's going on. And we have a cosine of 1213. So we're going to be using SOHCAHTOA throughout this problem. So I'm just going to put that, change colors here, and write SOHCAHTOA. This is how I prefer to write it. You'll see why in a minute. Okay, so the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, the tangent is opposite over adjacent. And let's go back to our problem here. And we're told the cosine is 12 over 13. So the cosine is adjacent over hypotenuse. So this is going to be 12 here and 13 here. Now we need to find this leg here, and we can do that with quadratic formula. So you'd have 13 squared equals, we'll call that h squared plus 12 squared. So this is 13 is squared is 169 minus 144 is equal to h squared. So 25 is equal to h squared. So h is 5. If you've been working with right triangles for a while, you probably recognize this as what we call a Pythagorean triplet. These are three numbers that work for the Pythagorean theorem. 12 squared plus 5 squared is 13 squared. The most famous Pythagorean triplet is the 3, 4, 5 right triangle. That's the one you see most often. But this other one is also very common, 5, 12, 13. Okay. So now we just need the rest of it. So we have the cos. So well, let's just work our way through SOHCAHTOA. So the sine theta is going to be opposite over hypotenuse. You can see the opposite is 5 here. They already gave us the cosine, which is 12 over 13. And we can see from SOHCAHTOA that the tangent of theta is going to be opposite over adjacent, so that's 5 over 12. Now you may or may not have learned the reciprocals, but we're going to do those now. So the cosecant, if you haven't learned this yet, it's okay. Just ignore it for now. The cosecant of theta, that's just the reciprocal of the sine, so we're just going to flip that sign. And then the secant here is the reciprocal of the cosine, so we just flip that. And then the cotangent is just the reciprocal of the tangent. And if you haven't seen these yet, don't worry. You'll be seeing them soon enough. And those are the 6 trigonometric values for this angle theta. That's all we're being asked to do here. And, you know, you're just getting started with trigonometry. And once you get used to it, it's not too bad. I think my best advice for kids who are starting off with trigonometry is just make sure you're drawing a diagram. 9 times out of 10, if you draw the diagram, you're going to have an easier time. And you should know your quadrants. I'll fill those in. This is quadrant 1 here. Quadrant 2 is over here. Quadrant 3, we use Roman numerals for our quadrant numbers. It's just a tradition. And quadrant 4 is here. So just get used to the quadrants, get used to sketching graphs, and I think you'll be okay. All right, so that's it for this problem. I'll see you again next time. Bye-bye.